Okay, so in this video, I would like to demonstrate some of the enhancements that have been made to the JPL Horizons module. So if you have an up-to-date version of Tycho and you are curious to know what changes or improvements have been made to that module, then this is the video for you. So to get started, there are three different ways that you can access this module. The first of which is through the Tools menu. So if you go to Tools, JPL Horizons Interface, and choose that option, it will present with a new window. Another way is through the Image Manager. So if you go to the Ephemeris menu, you'll notice that there are two options, one to attach from the FindOrb software and the other to attach from JPL Horizons. So this is another shortcut. It presents the same window, so you can access it in that fashion. And I will point out, FindOrb is also still a useful software for this purpose. So the use case there would be if you have a newly discovered object and it is not yet part of the JPL Horizons database. If you happen to have the measurements or the observations of that object, FindOrb will compute the ephemeris for you. But if it is part of the JPL Horizons database, then that can also be useful. So this module can be quite helpful. For example, the James Webb Space Telescope is considered a major body, so they would regularly update the ephemeris information of that object. Now, in this example, I'm actually just going to focus on a comet. So I'm just going to choose asteroid or comet number, or I could choose name or designation. But I'll also point out you could also choose if you have for example, a satellite with two-line element. That would also be another option. But again, for this demonstration, I have a comet. This is Comet Atlas that I'll be demonstrating here. So I can type in target ID of Atlas. Now you might point out that there are a number of objects with Atlas as part of their designation, and that is a true statement. And you might also point out that Atlas is not exactly a number so much as it is a name. However, we can just go ahead and see what will happen if we do this. So if I click on Check Object, then it comes back with this information. And already that is an improvement because in the previous version, it was not particularly helpful. It didn't really give you a whole lot of feedback or information as to what was happening. So the new version here gives you a lot more helpful information. So here you can see from the output window that it downloaded the response from the JPL Horizons server, and it in fact interpreted it correctly as a name as opposed to a number, and that name being Atlas. It also told us that there are multiple matching small bodies. So here's the whole list of objects that have Atlas as part of their designation or their name. And you'll notice that that actually coincides with this window here. So what it's really trying to do is it's trying to tell you that you need to be more specific about which Comet Atlas that you want. So in this case, I have these images are of Comet Atlas C2019Y4. So this is the record number. So once I identify it as such, I click Select Record. So again, C2019Y4 for this particular demonstration. So having done that, then the check object function, what it does for us is it tells us that, okay, here it was successful, it's outputting ephemeris information. In this case, it does so for the next 3 days. So by default, you just get that for the next 3 days. But I primarily use it just to basically validate that I have the correct object. So it says target body name is Atlas. Let me go scroll back up here. So again, it says it was Comet Atlas. So that's C2019Y4. And again, all of these parameters make sense. So I'm confident that this is the object that I want. So I can proceed to do ephemeris attached to dataset. So once I do that, you'll notice that all of these columns in the image manager have now been populated. So for example, every single image now has the right ascension and declination of that object, and consequently, because the images have been placeholder, they also have the X and Y coordinates as well. And from that, it can deduce whether or not the object is within the field of view for every single image. So to verify that, we can go to the image viewer, and I'll give it a moment here just to load these images. And so here is the field of view here. You can see it, and that looks like a comet. So maybe it is, maybe it isn't. But all you have to do is click on one of these images here, and because I have this option checked to follow object on selection, when I click on an image in the list, it will automatically go to that object. So there it is. So I can scroll through all of the images, and you can see that it tracks that particular object. I could also do an animation, so it will basically loop through all of these images. So that's nice, and that works quite well. Again, the main emphasis here, the main improvement that can be made or stated here in this video is that it provides a lot more useful feedback. So if you, especially if you have an object with multiple possible designations. Finally, the last thing I'll show here is that I've demonstrated it works well with the image manager. You can attach ephemeris to that, which is useful for that purpose. But also there is the session planner module. So if you wanted to know where that object might be, if you want to figure out where to point your telescope, then the session planner is useful for that. So again, you could have ephemeris attached from JPL Horizons, and it's the same kind of routine. You would basically say, here's a target ID that I care about, and you, in this case, rather than attaching to the data set, you would choose attach to session planner. So here you go, it has now populated the session planner, and it just did so with a start and stop date that I had previously defined, but you can always change that. So you could say, well, I want the start date to be the current time, and I want the stop date to be 3 days from now. So I could choose, I could click now, and then plus 1 day, plus another day, plus another day. So now we have the current time, and then 3 days from now, that would be the basically the interval. So if I then choose attach to session planner again, it will now populate once more. Now the reason it is empty, the list here is empty, is because we have a filter. And if I uncheck that filter and click refresh, now you'll see we have a lot more entries. So the filter I had applied basically has min and max on moon, sun, and target altitude. So if you want to ensure that the object will be at some elevation and that the moon and sun will be at some other elevation, then the filter is useful for that. And by the way, it takes that information derived from your current observatory. So in this case, this is an eye telescope in California location. So it's going to, again, you can refresh that filter for that particular observatory. Now, if I were to choose a different minimum on my target altitude, so I chose 0 rather than 30, now you can see we have a few entries start to show up. So it looks like the object will be low on the horizon for the next few days for this particular observatory. So it gets up to maybe an altitude of 21.6 degrees on the horizon. So anyway, that's about it for this video. I find this to be a very useful tool to use. So I just thought others might be interested to know what has changed, what has been improved upon. Again, the main focus being that of the additional output, the additional feedback that it gives you. So that's about it for now. Thank you for watching, and see you next time.